You ever looked at a database table with millions or even billions of rows and just felt that dread? You know the feeling. Deleting old data takes an eternity, queries slow to a crawl, and just doing basic maintenance feels like a nightmare. Well, today we're going to talk about a super powerful SQL Server feature that turns all that chaos into total control.
Okay, to really get this, let's use a simple analogy. Picture this. You're put in charge of a massive library. It's got 2 million books. Awesome, right? But here's the catch. They're all on one single gigantic shelf. No order, no sections, just one long line of books. How on earth would you find anything? It would be, well, pure chaos.
Now, what if instead of that one monster shelf, you had a nice system of neatly labeled drawers? You know, a drawer for History 2023, another for Science 2024, and so on. You wouldn't have to search the entire library anymore, would you? Nope. You'd just walk right up to the drawer you need and open it. That, right there, is exactly what partitioning does for your data. It's the difference between complete chaos and total precision. So here's our game plan for this explainer. We'll start with that data library problem we just talked about. Then we'll introduce partitioning as the smart fix, walk through how to actually build it, and then unveil its incredible superpower. After that, we'll cover the rules for using it wisely and wrap up with a big architectural takeaway you need to remember.
Okay, we've set the stage with the chaos of that giant data library. So what's the control? Let's get right into the smart solution, partitioning.
So what is partitioning, really? At its core, it's just the idea of taking one huge table and breaking it down into smaller, much more manageable chunks called partitions. But here's the really cool part, the magic trick. To your application, to all your code, to your queries, it still looks and feels like one single table. All that complexity is totally hidden under the hood. And why would you want to do this? Oh, the benefits are massive. We're talking way faster deletes because you can drop an entire chunk of data in an instant. Faster reads because the database only scans the tiny piece it needs, not the whole thing. Archiving becomes a breeze, maintenance like rebuilding indexes gets way simpler, and you even get better concurrency. It's a huge win for performance all around. All right, so I'm hoping you're sold on the why. Let's switch gears to the how. We're not going to get bogged down in a bunch of code here, but we are going to cover the 3 essential concepts you absolutely have to understand to make partitioning work. It all boils down to these 3 steps. First, you set up the rules with something called a partition function. Second, you tell SQL Server where to actually store the data with a partition scheme. And third, you just apply it to your table. Simple as that. Let's break them down real quick. The partition function. Think of this as the architect's blueprint. It's the brain of the whole operation. This is where you define the logical boundaries. You're basically telling SQL Server, hey, any data from January, it belongs in this bucket. February data, that goes in the next bucket. Crucially, this is just a logical plan. We haven't told the system where to physically store anything yet. It's just the set of rules for slicing up your data. Next up, the partition scheme. If the function was the blueprint, the scheme is the builder. This is where that blueprint meets the real world. The scheme takes those logical rules you just made and maps them to actual physical file groups on your disk. You could put them all in one place, or, and this is where it gets really powerful, you could spread them out across different physical hard drives for even better performance. And here it is, the magic moment where it all comes together. When you create or modify your table, you just add this one simple line. This on clause tells the table, hey, use this partition scheme, which uses this partition function, and apply all those rules based on the reading date column. And boom, just like that, your giant table is now beautifully partitioned. Now, for my favorite part. Seriously, if there is one single reason to learn about partitioning, this is it. We're about to unlock a genuine database superpower that will completely change the way you manage big data forever. We've all been there, right? You got to clear out, say, 3 months of old log data. So you write a standard delete statement, hit run, and the whole database just grinds to a halt. For hours. It locks the table, users start complaining, it's just a painful, slow, resource-hogging nightmare. The solution is a beautiful technique called partition switching. And listen to this. This is the most important part. It is not a delete. You are not removing rows one by one. All you're doing is telling SQL Server to update a few internal pointers. It's an operation on metadata, not on data. So, how does this magic work? It's incredibly simple, almost laughably so. First, you create another empty table that has the exact same structure as your main one. Then, you issue one single command, alter table, switch partition. This command instantly, and I mean instantly, moves that entire chunk of old data from your main table over to the archive table. And the result is, well, it's just staggering. An operation that used to take hours now takes milliseconds. Millions of rows are gone from your main table in the blink of an eye. There's no table locking. There's almost no transaction logging. It is, without a doubt, the single most efficient way to handle large-scale data archival and deletion. It's a total game changer. Okay, this is an incredibly powerful tool, but you know what they say? With great power comes the need to be smart about how you use it. So let's get into the practical rules for when you should, and, just as importantly, when you shouldn't use partitioning. So, when's the right time to pull this out of your toolbox? Well, if your table is getting up into the millions or billions of rows, check. If you have to regularly delete or archive old data, double check. And if your queries almost always filter on a predictable key, like a date or a region ID, then my friend, you are the perfect candidate for partitioning. But you gotta be careful to avoid these common traps. Trying to partition on some random ID column? That's useless. You need a good logical key. And please, don't forget to update your database statistics after you do a switch, or the query optimizer is going to get really confused. Creating thousands of tiny partitions can actually add more overhead than it saves. And finally, remember, this only speeds up queries that use your partition key. It's not a magic wand for everything. All right, let's wrap this all up by zooming out a bit. I want you to stop thinking of partitioning as just some nifty database feature and start seeing it for what it really is, a core part of your application's architecture. This quote from the source material absolutely nails it. This isn't just about making one query run a little faster today. This is about designing a system that can handle massive data growth without breaking a sweat. It's the difference between an app that eventually chokes on its own data and one that's built to scale for years to come. And that, really, is the ultimate takeaway. Instead of spending all your time trying to tune complex queries to run against a giant messy table, change the structure of the table itself. If you think about how your data is stored and accessed right from the beginning, you can build systems that aren't just fast, they're fundamentally more scalable and easier to maintain. Don't query harder. Structure smarter.